Mr. Clelland here from Clelland Maths. It is a crisp New Year's Eve on 2025, and this is your ultimate higher applications in maths 2026 prelim revision guide. It goes through every single topic that you would possibly need for higher applications in maths, and it is absolutely freezing out here. But I just thought I would make this on New Year's Eve as a little gift to all my higher applications in maths friends. The PDF you can just get in the link in the description, and it goes through every single topic. It has files for Excel, RStudio, everything you would possibly need. So get on that. And if you want some extra help, I've also got my higher applications in maths members only masterclass and lots of members only stuff as well if you want to get on that too. Have fun, take care, and I'll see you soon. Basically, higher applications of maths 2025 question 4. A company makes handmade teddy bears. The tasks required to make each bear are listed below. The Gantt chart shows the task with float times when 3 employees are available, but each employer does a single task. So the tasks are in hours, and we've got all the tasks down the side. And in a minute, we're going to ask the critical path and to make a pair chart. So state the critical path first of all. Well, that's just the task with no float. A, B, H and I, and they all go into each other. So A, B, H and I to start with. So now to fill in one of these, which is a pair chart, we need to work out how do we read a Gantt chart to get back to a pair chart. So usually when you've got a pair chart and you're going to a Gantt chart, let's say that was task A. And then we'll just put A, B, H and I in to start with. Well, we know that looking at A, it starts at 0. It takes 2, and because it's critical, it has to end at 2 as well. And that's what that shows. It starts at 0, it takes 2, and it ends at the end of day 2. If we look at B, it starts at 2, it takes 6, and it ends day 8. 2, 6, 8 then. Let's do the same for H. 8, 1, 9. And similarly for I, 9, 10, 9, 1, 10. Now I've put this in the middle. It doesn't matter whether it goes there or whether that and that become A, B, H and I. You'll get the same answer. So now we move on to the other tasks. So looking at the other ones, we have to have a continuous path. So we can actually look at our tasks as well. Cut materials, sew clothes, embroider t-shirts seem to go together. Cut accessories and sew accessories seem to go together. And does that agree? Well, if I look at C, we've got C, have some float time, but that's fine. D, E, but then the float time because A and B lead into that already, so we need it to end there. So that's right, C, D, E, H, I. So we can put C, D, E, H, I. And similarly for the other ones then, F and G, well F goes into G, and then G has to wait till B finishes, then H, I. So F, G, H, I makes sense for the other ones. So then we'll just put in our earliest, our duration, and our latest end time. So let's start off with the bottom, C, D, and E. 0, 2, 4. D, 2, 2, and then 6. E, 4, 2, 8. And then moving at F and G. F starts at 0. It should take 1, but we can go all the way to the end of day 6. 0, 1, 6. And G starts 1, takes 2, but we can go all the way to day 8. So 1, 2, and 8. And there, that should be a completed pair chart. We can check if that makes sense. So let's have a look at doing it the way we would normally do it. 0 plus 2 is 2, 2 plus 6 is 8, 8 plus 1 is 9, 9 plus 1 is 10, 0 plus 1 is 1, 1 plus 2 is 3, but it's the longest we need, so 8's fine. 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2, but it's the longest we need, so it's 8. Going backwards, 10 minus 1 is 9, 9 minus 1 is 8, 9 minus 1 is 8, so 8, 8, 8. 8 minus 2 is 6, 6 minus 2 is 4. 8 minus 6 is 2, 8 minus 2 is 6, so it appears to be right. Question C, determine the minimum time taken to make each teddy bear when only 2 employees are available. Now remember, these tasks have to come after these tasks. So you can't just randomly go in and do tasks. But what you can do is having simultaneous work. So let's say we had, let's call that employee 1 and employee 2. Employee 1 does A, while employee 2 does C. Then employee 1 could move on to B, or we could move on to F or G. So let's say we just move on to B. Well, that means that employee 2 can do D. Now, while we're doing that, that's 2. So we could do something else that takes 2. Well, that's E. And then what's left is F and G to be done. Well, employee 1 is still working on B. So there's no choice but for employee 2 to jump to F now. Now employee 2 jumps to F. So they're doing C, D, F. That's 2, 4, 5. An extra hour there. And then they do G. So that means that when this person's finished doing A and B, we need to wait an hour until G is finished. And then it doesn't matter who does H. Somebody does H, then somebody does I, but they come after each other. So that's kind of your idea here. So if you look at your durations, A and B become, that's 8 hours. But C, D, E, and F is 2, 4, 6, 8, 9 hours. And then you've got 1 and 1 for each of them. 9, 10, 11. So it's 11 hours. It doesn't matter how you divide that up, it's always going to be 11 hours for 2 employees.
Basically, Higher Applications of Maths 2023, question 2. In a coupon competition, a contestant has 80 minutes to make a creme brulee. There are several tasks to complete, with contestants' timings are shown for each task below, and we have to complete a pair chart, as shown below. So let's go to the pair chart, and then I'll open up all the tasks at the side so we can see exactly what's happening. So there's all the tasks, I'll just zoom into them. And we have got to make 3 scans of this. We need to do our standard, then a forward and backward scan. Okay, so let's start off with middle boxes. First thing we need to do is heat the oven, that's A. So let's write down A, maybe in here, and that takes 8 minutes. And then at the same time as that's happening, we need to gather ingredients and prepare the bowls, that's B. And that takes 10 minutes. Okay, so we've done these, I'll just make a little note for myself. Now we need to move down. C comes after B. So maybe C in here, and that takes 5 minutes. Also coming after B is D, and that takes 4 minutes. So they're happening simultaneously. After C and D, it says, is E, which takes 2 minutes. So there's E and 2. After E, it says F, and F takes 4 minutes. And now we need to get our next ones right, so let's just move that over. So after A and F, we've got G, and that takes 35 minutes. After F, we've got H, so just after F, that goes down the way to H. So that takes 12 minutes. And then after G, we've got I, which takes 3 minutes, and J, which takes 5. So we've done our forward scan. We can kind of get rid of this document now, we don't really need it. So let's do our forward scan. We've got 0 to start with here. And then moving on to the B, that also starts at time 0. And then 0 plus 10 is 10. So we've got 10 is when this starts. This one also starts at 10. And then looking at this next one is the key one. That is 15 because I need to wait until this one finishes. So 10 plus 5 is 15. And 15 plus 2 is 17. 17 plus 4 is 21. So this will both be 21. 21 and 35 is 56. So that'll be in highs. 56 and 3 is 59. So that'll be in ji's. And down below, you've got 21 and 12. We've already done that one. So we've done the forward scan. So let's now do the backward scan. So starting off at the end, 59 and 5 makes 64. So I can put 64 here. Now going back away, we've got 59 because 56 and 3. Then we've got 56 because 35 and 21 is 56. And on this one, we've got 21 and 12, which you might think makes 56, but this is the key one, H. Because H is at the end, and then I need to wait till J, then that's actually really 64. So that's a key one there. You need to get that one. All right, let's move back to F. F is 21, 17 and 4. E is 17. And then we've got C and D. Again, they're going to be not just 10 and 15 and 14. C is 15. D has to wait, so that's also 15. And then back to B, we've got 10. A is a key one as well. A is having to wait until we get to here, so that's 21. In other words, it's the same as F, so it has to wait until F finishes. So there's a completed chart there. Let's see where we're getting the marks for that. So 6 marks this was worth. We get the first 6 tasks in the correct sequence. We then get a mark for the remaining 4 tasks and durations in the correct sequence. So basically getting your tasks in the correct order with the middle boxes gets you 2 marks. And then your forward scan from A to F being correct, so up to here, if all of that's correct, you get a mark. You then from G to J, if that's correct, you get a mark. And then backward scan J, I, H, and G. So you need to get all of them to get a mark. And then finally, to get the rest of them, you get another mark. So there's ways to make a wee mistake and still get your marks, okay? Right, let's answer the next part of the question. Part B says, when the contestant puts the balls in the oven, they realise the oven has not been heated to determine whether they can finish on time. So remember what these tasks were. Task A was to heat the oven, right? So that's not happened. They've went straight to task B and they've not heated the oven and they've got 80 minutes to complete the task. So we can say that since it actually takes 64 minutes, there are 16 minutes spare. So I can write 16 minutes spare. I worked that out by doing 80 minus 64. And then we can say it takes 8 minutes to complete task A. So can they still finish on time? Yes, since A is less than 16 minutes. So for marks for that one, you're getting a mark for either saying it's 8 minutes to complete task A over 16 minutes spare, and then a mark for saying yes because 8 is less than 16 or 16 is greater than 8. Okay, done there. Let's go to Higher Applications of Maths 2023 question 6. The Gantt chart below shows the activities used to complete a project. A is dependent on F and H. F is dependent on B, C, and E. E is dependent on D, and activities C and B are dependent on A. What does that mean? Well, that means that if you look at A, you need to do A first before you go on to B and C. If you look at E, you need to do D first before you go on to E. If you look at F, you need to do B, C, and E first. B, C, and E before you go to F. And if you look at G, you have to do F and H first before you move on to G, which is what a Gantt chart usually shows. So, state the critical path. If we look at here, I can't move on until after D. I need to wait until A. So I need to do A first. So A is our first thing. After A, E's already started, so it's not that. I'm now moving on to the next activity that I can do, which is either B or C. But B only lasts 2, C lasts a lot longer, so it's C. Now after C, I'm at here, moving up my Gantt chart, I can see I've got 2 activities that I could choose from, but that stops before this one ends. So I need to finish this one first before I move on. So that's F. And then clearly after F, there's only one activity left, which is G. So the answer is A, C, F, and G. Part B, state the duration of the float time for activity B. So let's look at activity B. B and C are happening simultaneously. So there's 2 hours done. So I've got 1, 2, 3 hours left over before C finishes. So the float time is 3, not hours, sorry, days. Because the units are days. Make sure you put your correct units in. And then the last question, just talking about what a Gantt chart is and its advantages. State an advantage of a Gantt chart. Well, a simple reason which is worth the marks is that it's clear and simple to read. So you can just write it's clear and simple to read. Other options, looking at the mark scheme, any other reasonable explanation. So another one that you could have been taught is that it's easy to see the float times, because it is easy to see the float times from the bars.
SQA Higher Applications of Maths 2025 question 2. A group of gym members were asked what machines they regularly use from a choice of treadmill, row machine and cross trainer, and you've got all these results. We have to complete the Venn diagram to show this information. So always start with the one in the middle. So the one in the middle is all 3. 4 members use all 3, so 4 goes in the middle. And then we can start working on our double choices. So 38 members use treadmill and rowing machine. So treadmill and rowing machine has to add up to 38, but I've already got 4, so I've got 34 left over. 32 use cross trainer and treadmill. So again, cross trainer and treadmill has to add up to 32, but I've already got 4, so that leaves 28 left over. And then 15 use rowing machine and cross trainer. At the bottom, the intersection of that is 15, but take away 4, so I get 11 in this box. So there's my boxes filled in for that. Then we go on to our single boxes. 90 members use the treadmill, 90 in total though, so I need to take away, it's not 90 only use the treadmill. So 90 minus 34 minus 28 minus 4 leaves 24 left for the treadmill. 85 used the rowing machine. So again, for the rowing machine, you've already got these numbers in its circle. So it's 85 minus 34 minus 4 minus 11, leaving 36. And then finally, 53 used the cross trainer. So it's 53 minus all of these numbers, 28, 4, and 11, which gives me 10. A number that sometimes people forget to do is, well, none. 13 use none. We can either get that from the question, or if it gives us a total, we can take away all the numbers to get it. Complete the Venn diagram. We're done there. A gym member is selected at random. Determine the probability that they regularly use the rowing machine and the cross trainer, but not the treadmill. So rowing machine and cross trainer, there's the cross trainer, there's the rowing machine, there's the intersection between them. So it's 11. Use both, not the 4, because that's for treadmill as well. You have to use the rowing machine and the cross trainer, so it's 11. So 11 is my top number. And my bottom number is 24 plus 28 plus 10 plus 11 plus 36 plus 34. So if you've went around the way I've just done, you've done all of these ones here, and you've missed the 4 in the middle. I mean, I've also missed, of course, the one on the outside. 160. 11 out of 160. It's a fraction. You could change it to a decimal if you want, which is not very great. Percentage would be better, so times by 100. About 6.88%. But I'm happy that the fraction would be fine as your answer. SQA Higher Applications of Maths 2025 question 7. An events management company has been awarded a contract to construct stages for a music festival. If construction on stages is delayed, the contract says a penalty will be paid of £25,000. 2 things that can happen: stage structure fails or staff fail to attend site. The probability of no delay is 0.76. Calculate the expected cost of a delay. So the probability of no delay is 0.76. So that means that the probability of a delay then is the opposite, no delay or delay, only one can happen, is 1 minus 0.76, which is 0.24. So there's a probability, so that means our expected cost is simply 0.24 times the penalty of 25,000, calculator, £6,000. Number 7 continued. The company is considering the following control measures. They can pay another company to have staff on standby and it costs £1,000, or they can have a spare stage on standby at the cost of £1,500. The probability of staff failing to attend is 0.2. The probability of a stage structure failing is 0.05. Calculate the expected cost of control measure 2. So for part B, control measure 2, have a spare stage on standby, and that costs £1,500. But then we need to add on, still somebody could fall ill. So we've still got 0.2 times £25,000. So we can work it out in a calculator. 1,500 plus 0.2 times 25,000 is £6,500. And then the expected cost of control measure 1 is taken as £22.50. They must have worked it out for us. The company will only use one control measure, explain which one they will use to minimise expected costs. Let's just check that that's £22.50 for the sake of it. So if it's £22.50, that's because the structure could still fail at £25,000. And then we're adding on £1,000 for the cost of control measure 1, which is £22.50. So that's where we got that number from. But we know if you do nothing, it's £6,000. If you do control measure 2, it's £6,500. So we should do control measure 1. As £22.50 is less than £6,000 and £6,500. So control measure 1 gives the least expected costs. And we're done there. The Higher Applications of Maths 2022 question 1. Jill borrows £56.50 from a bank. Annual effective interest rate is 9%. Jill makes level monthly repayments of 18601 at the end of the month. Complete the loan schedule for Jill's loan to show the loan outstanding at the end of month 2. So first of all, we need to work out the monthly interest. So we turn that 9% into 1.09. 100 plus 9 divided by 100. So it's 1.09. And it's the power of a 12 because it's 1 month. So if I do that in a calculator, you'll see that I get 1.09 to the power of 1 over 12. That's 1.0072. So we then need to obviously take away the 1 and times by 100 to change it back to a percent. So I need to take away 1 and times by 100. So there it is there. Take away 1 times 100 and we get 0.720732. 0.72%. Now, when you're doing your table, you can use 0.72%. You would even get away with 0.7% or the full amount. I'm just going to use 0.72 because it's easier to do the sums in a calculator than having to keep this one going the whole time. Just when you check the mark scheme yourself, make sure you look at the different options that are available. So this one will be for 0.72%. Okay, so let's start off. I want the interest content of repayment. So the interest content is we take the percent and times by the loan outstanding. So it's 56.50 times 0.72%, so divide by 100, and that gives me £40.68. So I'll put that in this box here. Capital content of repayment, well, that is just your repayment minus your interest. So the repayment's 186.01 minus your interest which gives you 14533. And the loan outstanding is the previous loan outstanding minus the capital content, because interest doesn't go towards it. So that's 550467. And then we start again. So it's £5504.67 times 0.72%, £39.63. 18601 is the payment minus the £39.63 to give 14638. And finally, loan £5504.67 minus the £146.38 to get 5358.29. And we're done there.
Higher Applications of Maths 2025 question 6. You must refer to information on lifetime ISA given the pre-release. Morgan owns a lifetime ISA with a Berlin bank. The online account has an effective rate of interest of 3.25%. Morgan makes a deposit of $2,500 into her account on the 1st of January 24. So I'm setting up a timeline, $2,500. The government bonus is paid into her account on the first day of the following month, on the 1st of the 2nd, 24. She makes no further deposits in 24. Calculate the accumulated value of Morgan's lifetime ISA on the 31st of January 24, which is the same as the 1st of January 25, essentially. So we need to work out what this bonus is. So lifetime ISA pre-release material says you can save up to £4,000 a year as a lump sum or put in cash in when you can. The government will add a 25% bonus to your savings up to a maximum of £1,000. The bonus is paid every month on new deposits that have been made. So the bonus is paid on the deposit. So we made a deposit of £2,500. So our bonus on that deposit is 25% of £2,500. So 0.25 times 2,500 is 625. So I can just I'm putting in 625 there. So now I just need to work out my interest. 3.25%. So 1.0325, add 100 divided by 100. And I want it for 1 month for that time period. But that's out of a year. So it's out of 12 months and I want 1 month. And this one's still 1.0325, but is now 11 months out of 12 months. So my sum, that was 625, remember, is just going to be 2,500 times 1.0325 to the power over 12. Then I need to add the 625. That's step 1. 2,500 times 1.0325 to the power of 1 over 12 plus the 625 is 3131.67. So then I start again from 3131.67 times 1.0325 to the power of 11 twelfths. 3131.67 times 1.0325 to the power of 11 over 12 is £3224.84. And we're done there.
Maths 2022 question 4. Zach puts £500 in the bank on the 1st of January 2018, 19 and 20. The effective rates are 3.3, 2.4 and 1% per annual or year. And he makes no withdrawals. Find the balance at the end of 2020. 2 ways to do this. I'm going to do it by a timeline method. So we've got 2018, 500, 2019, 500, 2020, 500. And then we'll go to the end of the year, 2021, but nothing goes in. So our interest rates, we do 100 plus the interest divided by 100 to make it into a decimal multiplier. So that would give me 1.033. Use a calculator if you want. 1.024 and 1.01. So we'll start off with 500 times 1.033 and then add 500. So the first one is £1016.50, and then start again. 101650, 1.024 this time, plus the 500 at the end of that. And you get 1540.896 or 1540.90. And then we start again. 1540.90 times 1.01 is 1556.309, so 1556.31 to 2 decimal places. Just not the mark scheme of this, the SQA decided it to be 1556.30 instead of 31, but they did say 31 would be an acceptable answer due to rounding, so I think the rounding's fine. Okay, on the 1st of January 2021, Zach deposits another 500 in his account, makes no further deposits in his account, calculate the annual effective interest rate needed for 2021 for the balance to be 2100. So we'll look at present value here. We'll start with 2100 and we're dividing by how much is in his account. Well, he's got 1556.31 plus the extra 500. You can use a calculator if you want to get 2056.31. So if I divide them together, I'll get the decimal multiplier, which I might need to change to percent. So let me just divide them together first so you can see that. 2100 divided by 2056.31. That gives me that. So you now should be able to see quite clearly that at the end of that sum I have to take away 1 and then times 100 to change it to a percent. So I'll take away the 1 now, press equals, times 100, press equals, and we get 2.12, a bunch of other numbers, percent, and we're done there. We have against Maths 2022 question 6, the average price of petrol increased at the following annual effective rates: 2.1, 0.5 and 2.0 from 2018 to 2021. And we have to work out the average price, the overall percentage increase in the average price of petrol over these 3 years. Now don't be tempted to just add them up, that is not it. Imagine if I started with £100, I would do 100 times 1.021 times 1.005 times 1.02. I would times them by the decimal multipliers. So I need to times them together to get the overall percentage increase. So in other words, I do 1.021. I got that by doing 100 plus 2.1 divided by 100 times 1.005 times 1.02. Once I've done that, you'll see in a minute, we can do it in bits. 1.021 times 1.005 times 1.02. That gives you 1.046627. So with that answer, I'm going to have to take away the 1 and times 100 to find it back into a percent. So take away 1, times 100, 4.66, and a bunch of other numbers, 4.66%. Average price of petrol in 2021 was 136.4 pence per litre. Calculate the average cost of filling a 45 litre tank with petrol in 2018. So we're going from 21 back to 2018, but we already know that the percentage that increase was 4.66%. So all I need to do is divide by that to go backwards. So 136.4 divided by 1.0466. So getting my calculator back open for that, 466,271. I'll just divide by 1.0466,271. That gives me 130.323. So I then need to times that by 45 because it's 45 litres. So just times straight away by 45. That gives you 5864.55 and a bunch of numbers. But that's going to be pence. Now pence looks a bit nasty to me, so I'm going to divide by 100 to get £58 and 645, so 65 pence. 58.65. Due to rounding, you'll get 58.65 or 64.63, and that'll be completely fine. Next, we have Higherapps Maths 2025 question 3. You need to refer to deductions from salaries. Elena earns a gross annual salary of $24,960, pays 8.2% of her gross annual into her pension, and pays $82.56 national insurance per month. What is her net monthly salary? Okay, so for this question, we don't need to work out the national insurance. We just need to work out the tax. So you can ignore the national insurance part of the data booklet and just grab the tax bit, which is here. But don't be so hasty. With pension, you need to take that off first before you calculate tax, not before you calculate national insurance, but before you calculate tax. So I need to work out our taxable pay. So it says 8.2%. So I could just do 100 minus 8.2 to leave 91.8%. So 24960 times 0.918 will tell you her wage once you take off the pension. Now, if you don't like that, that's completely fine. You can just do 8.2% and take it off. And in any case, you will get 22,913.28. And we'll then use that with the tax table. So there's our tax table. So personal allowance 0. For starter rate, we just do the bands 14,876 minus 12,570 times 0.19. Which is 43814. We now move on to the basic, always bearing in mind what their wage is. The wage, remember, is 22,913.28. Well, that's above this number here. So I use their wage minus 14,876, 22,913.28. Minus 14,876 times 0.2. To get 1607.46. Rounding up. So total tax is £438.14 plus 1607.46, which is 2045.60. So now we need their net wage for the month. So you could work out the total national insurance for the year and take everything off, then divide. Or at this stage, you could just take away the tax and divide by 12 and then take away the national insurance. And I think that's the quickest way. So that's the way I'm going to do it. So I've already got our taxable pay. So I've already took off the pension. So I can just do £22,913.28 minus my total tax of that. And then divide by 12. Being as efficient as I can by using my calculator's brackets. £1,738.97. So that means that our net month pay is 1,738.97, and the only thing we've not took off is the national insurance given to us in the question, which is 82.56 per month. To get a grand total of 1656.41. And we're done there.
SQA Higher Application of Maths 2023 question 4. It says you must refer to the information on tax bands 2022-23 given in the pre-release material when answering this question. Key points, so you need to go and check that booklet, so let's do it right now. So there's the tax bands there, copied in from the data booklet. Now it says James works in a large building company as a permanent employee and he has a gross annual salary of £36,700. James pays 4.7% of his salary into his pension, and then he pays 307,145 national insurance. So we don't need to work out his national insurance, it's given to us. Calculate his net annual salary. Net is after you take everything off. Now, we have to work out his tax. Remember, this is a one key thing. If you're working out someone's tax, you take the pension off first. If you don't do that, you're going to lose a mark. So taking off his pension, I need to take away 4.7%. Two ways to do that. Just work out 4.7% and then take it away. Or I'll always use multipliers when I get to higher. So I'm going to do, in my calculator, 100 minus 4.7, because I'm taking away 4.7. That's 95.3. So I'm going to times his salary by 0.953, and that will give me what his salary is after the pension's taken off. So I'm going to do 36,700 times 0.953. 0.953 times 36,700 is £34,975.10. 34,975.10 is his taxable. Right, now we need to use our table to work out the tax in each band. So we'll just do it line by line by line. So first line, we pay £0. Second line, well, his wages way above that. So I need to do for the second line, I'll just put a little dot, 14,732 minus 12,570, because that's the two bands, times the percent as a decimal, 19%, 19 divided by 100, 0.919. Now usually we just work these out separately instead of one big sum, so I'm going to do that one there. 14,732 minus 12,570, you can put brackets around that or just press equals, times 0.19, and you get 41078. So I'll just take a note of that, 41078, and then we'll do our next one. So our next one is this one. Let's call that I. For II, again, the highest there is 25,688, which is still below his salary. So I'll just do 25,688 minus 14,732 times 20% this time, so 0.2. So calculate again, taking my time, 25,688 minus 14,732 times 0.2 is 2191.2. So 2191.20. Okay, that's II done, II. That'll be this one. So in this case, I'm in intermediate now. 43,662 is above his salary. So I'll do his salary minus the lower. So his salary is 34,975.10 minus 25,688 times the percent, which is 0.21 this time. So again, calculator, 34,975.10 minus 25,688 times 0.21 is equal to 1950.29. So his total tax, I just add up all the tax that I just worked out. $410.78 plus 2191.20 plus 1950.29 is 4552.27. So now his net pay, I just take his total pay and take away everything. Well, I don't need to start with his total pay actually, because I've already taken away the pension, which is down here. So we can start off with the taxable bit and just take away the national insurance and the tax. So his net pay is 34975.10 minus his tax, which is 4552.27, minus his pension, which is 307145. So getting the calculator and being careful I put everything in right. 34975.10 minus 4552.27 minus 3071.45 equals 27351.38. So pound sign 27351.38. Okay, let's briefly go over where you're getting the marks for this. Let me just check this. So you're getting the mark for obviously your final answer. That is clear, but taxable income. If you get 34,975.10, if you take away a pension, you get a mark there. So let's just take a note of that here. There's a mark there. And then you get calculate the tax for starter, basic and intermediate band. So basically calculating all these taxes, you get a mark. You get a mark for calculate tax for the remaining bands and total tax to pay. So, starter, you actually get a mark for doing 0, then these two, and then a mark for the final band and the total. So you get a mark there, and then a mark obviously for your final answer, add them all up. SB Higher Applications and Maths 2023 questions 9. The Consumer Price Index, CPI in the UK in April 2021 was 110.4 relative to a baseline of 100 in April 2015. Explain what this figure means in terms of relative purchasing power. So purchasing power is how much you can buy, basically, based with a certain amount of money. 110.4 against 100 means that I can buy the same amount of goods in 2021 with £110.4 as I could with £100 in 2015. The minimum thing you can say to get a mark is purchasing power has decreased, but I would probably say, expand on that and say £110.40 can buy the same amount of goods and services in April 2021 as £100 could buy in April 2015. Simple as that. Right, the price of a new 3-door car rose in line with the CPI between April 2015 and April 2021. In 2021, the price of a new 3-door car was $14,108. Let me take a note of that. 14,108. Calculate the price of a new 3-door car in April 2015. So the consumer price index relative to 100 is 110.4. So I can do 110. I need to divide, because I'm going back to the original, by 110 over 100. So 110.4 divided by 100 is a decimal, 1.104. So I need to divide by 1.104 because it's went up by 1.104. So taking my calculator, I get 14,108 divided by 1.104 is 12,778.99. £12,778.99. Okay, the national living wage is the minimum hourly rate to be paid to an employee 23 years or older. In April 21, the national living wage was £8.91. This was raised to £9.50 in 2022. Given that the CPI in April 2022 is 119.0, determine if this rise is in line with inflation. So our new CPI is 119 relative to 100. If we divide them together, that gives me 119 divided by 110.4, 1.0078, 1.0778. So the national living wage was £8.91 and it's been raised to £9.50. So you could compare the fractions, or you could just take £8.91 and calculate what it should be. So times 1.0778. So £8.91 times 1.07789, I think it was, is £9.60 roughly. £9.60 is what it should be. So the national living wage was increased below inflation. And we're done there.
SQA Applications of Maths 2024 question 9. You must fit the spreadsheet Esme's mortgage. Complete parts A and C and then complete it in the letterbox provided. Okay, Esme is building an extension to her house. She has been offered a £25,000 mortgage with an effective annual rate of interest of 3.5% over 5 years. Open the mortgage worksheet, complete the mortgage schedule to determine the level monthly repayment amount and final repayment amount. Okay, so there's a spreadsheet, 25,000 annual, so we need to go monthly, so that equals 1 plus the annual to the power of 1 over 12, and then you need to take away 1. So you get 0.29%. Level monthly repayment, no idea. This is a goal seek question, so let's just make it up, £300. And let's start filling in our schedule. So that equals this one, but that's outside the table, so you need dollars. Interest content of repayment equals round, because we're going to do it to 2 decimal places, and it's monthly effective rate times the mortgage outstanding, 2 decimal places, but we want dollars on anything outside the box. So $C, $9, that's looking good. Capital content of repayment, well, that's just repayment minus interest. They're in the boxes, so no dollars. And mortgage outstanding just equals mortgage outstanding minus capital. And how many payments? 60. So now we can just copy that down for 60 months. And we want to do a goal seek. So we want to make this 0. So we're going data, what if analysis, goal seek. We want to change that to 0 by changing cell, well, the level monthly repayment, of course. So OK, that'll run its little thing, press OK. But as per usual, although it says 415.18, that's actually been rounded or truncated, so I would round that or take away the 9, it's up to you. You can go up to 8 or down to 7, it makes no difference. I'm just going to make it 8. So there's my actual repayment, it'll adjust itself, and that means my final payment's off by this much. So that means I need to take away 0.06 from 415.18, so minus 0.06. And then we get back to 0, is what we need. So 45412 is our final repayment. Either type it in or reference the cell. Okay, back to here. Esme's new building insurance once the extension is complete. She's choosing between 2 options. This one, cost per year is £216.94 for £350 excess, or £285 to £195 for £100 excess. Stated one advantage of having a high excess amount on your insurance policy. Well, even just if you didn't know, if you look at it, a higher excess is giving you a smaller cost per year. So that's all you need to type. Higher X, I'll just get rid of that. Excess gives a smaller cost per year. So that's 1. That's an advantage. Part 2, one of the windows in Esme's house is broken. She says whether to make a claim. Explain why Esme may choose not to make a claim using her insurance policy. There's lots of reasons for that. It might mean that her premiums go up in later years because she's made a claim, or it might be because the excess is too high and it's cheaper just to fix a window without making a claim. It could make her premiums more expensive in later years if she claims. It could be a reasonable option, or maybe you would say that it may be cheaper to replace the windows herself rather than paying the excess. Could be something like that as well. Okay, the maximum monthly repayment amount allowed by the lender is £550. Esme chooses to reduce the term of the mortgage by increasing her maximum monthly payments to the maximum amount. Open the increased worksheet. Complete the increased payment schedule for reduced term and calculate the final repayment amount. Determine how much money this would save Esme over the term of her mortgage. So there's the increased payments amount. 25,000, 3.5% annual. So we can work out the monthly as usual. 1 plus this power 1 over 12 minus 1 is our monthly interest. So how long is this for again? No, we don't know. Interesting. So we're actually going to have to guess or work out how long it takes her and do a monthly payment. So we're just going to copy down until we get 0. That's interesting. So the repayment is always going to equal this, and that's dollar. We're not goal seeking this is a repayment. Interest content of repayment, as per usual, equals round. And we're going to do this times the monthly effective interest to 2 decimal places, and make sure you put dollars on anything outside the table. Capital content, that equals the repayment minus the interest, and mortgage outstanding equals the mortgage minus the capital. So now all we're going to do is copy that down and see what happens. We're not going to go above 60, of course, because we already know it takes 60 months on the previous one. You're going to have to keep doing it until... So you can actually see after that amount, we've went too far. Because you're starting to get minuses. So we can just take them away. Take them away. And that means that the repayment on month 49 is just 427.19. And you'll get your 0 there. So there you go. 427.19 is the final repayment amount. Determine how much money this will save Esme over the term of her loan. All we need to do is do a sum here. So let's do that at the side. Equals sum all of these. So there's the sum for that one. And the mortgage before equals sum of all of them. So there's your two totals. So we could just do equals this box minus this box. It's not worked, has it? If it doesn't work for you, just check the number 2725074. 27250 minus, let's just click that box now. Right, we'll give it 42355. Could have also done this just by doing the difference in the interest, but there we are. And then the last bit of the question, print in mortgage worksheet in value and formula and increase in value and formula. I hope you know how to do this, but by now there's your value view, and you just got the formulas and show formulas and then print it in formula view. And just do that for both of them. Value view, formula view, and we're done there. Higher Application Maths 2025, question 8. You must refer to spreadsheet file Q8, finance, when answering the question. Martin is buying a car for £7,500. The garage offered Martin the finance package below. 20% deposit, 35 level monthly repayments of 216.77, final monthly payment of 216.13. If they open the worksheet and complete the loan schedule to work out the annual interest rate. That's a goal seek then. And then we've got a part B of this question. Okay, so in the Word document here, so in our Excel document here, initial loan amount. So the cost of the car is 2,500. If you remember back in the question, it said there was a deposit, and the deposit was, reading the question myself, 20%. So that means that 80% is left. So we could work that out by saying 0.8 times this, and that gives me my loan amount. Or you could have just worked it out manually and typed it in, no big deal. So take it off 20%. Annual effective rate of interest. Well, it told us to work that out, so who knows? So I'm just going to guess one. 30% is my go-to guess for percentages, so I type 30. And now I need the monthly effective rate of interest from that. So that is the standard command equals 1 plus our interest rate to the power of 1 over 12. And then you need to remember to take away the 1. And that will generate the monthly interest rate. Loan period is 36 months. It tells us the repayment and the final payment, so I need to copy that in. So then we have to fill in our table. So this one just equals this one with dollars, which you can press F4 for quickness. Interest content of repayment. Well, that equals, we're going to round to 2 decimal places at this point. So put that in. So we need to do the loan outstanding. Now that's not dollar because we're inside the table. Times the monthly interest. That is dollar because that's outside my table. Comma 2. Now it doesn't matter whether you put interest first, then F17. The order doesn't matter for timesing. We get an answer. Capital content, well, I've already rounded, so I don't need to do it again. So this just equals our repayment minus our interest. So this is exactly the same as doing a loan schedule that we've done loads of times. And then loan outstanding equals, well, loan outstanding minus the capital. Press enter. And then we can just copy down. So, drag my little box. And just remember that final payment we need to change. But that's okay. We can just change that here by looking up to see what box we're on. Final repayment is in C13, I think. So I'll just edit that to a 13. And it'll change that there, which means it'll change that there. So now, obviously, what we're expecting is you take a loan out, at the end it should be paid, and it isn't. So we need to go seek our interest, because obviously the interest is wrong. So we press the box, we go to data, what if analysis, goal seek, set cell F53 to value 0 by changing, so we go up, and it's the initial interest that we guessed, the 30% one. Press OK, that will do its thing, press OK. You should get 0 in here, and we've got a 0, so we're good to go. So our interest rate has been calculated as 19.5. Now you might be thinking to yourself, do I need to edit this? Because usually I've been told I need to take that back down to the correct decimal places. No, that's for money. If you edit this now, what's going to happen is you'll no longer get a 0 here. So the answer is 19.50022009305, and that's what the bank will use to calculate your payments. But we'll just quote it to you as 19.5%. That's it. So it's 19.5%. I'm going to type that in there, but obviously we're going to print this out in a minute, so we'll just print it out. Car insurance is a legal requirement for cars driven in UK roads. Explain the purpose of car insurance for 1 mark briefly. Essentially what car insurance does, it gives you protection financially to road users. Provides financial protection, I'll say, and you could be more or less. Not just for car users, for road users in general. So to write a bit more about that, just in case the SQA are really wanting it to be expanded upon, or what is only worth 1 mark. In an accident, insurance will pay for damages, say, to car / injury, even if you can't pay. You'll also get accidental damage cover, you'll get cover for fire, theft, vandalism, and obviously peace of mind. But the legal requirement really is that in the event of something happening like an accident, the insurance will pay for damages to your car or the other person's car, depending on who's at fault, and therefore it doesn't really matter if you can afford to or not, because cars are very expensive things, the insurance will cover it. And there we are. 8 continued. Martin has been saving for a deposit in car insurance, and he opened a savings account with an initial deposit of £500 on the 1st of August 2023. He made regular monthly savings of £250 into the account on the first day of each month from the 1st of September 2023. The effective rates of interest are as follows. August to November in 2023, the end of, is 0.24% per month, and for the 1st of December, 3.1%. With the open savings worksheet, calculate the balance in Martin's savings account immediately before he makes his payment on the 1st of August 24. Okay, let's do that. Already got some stuff filled in for us. His initial deposit is £500, which it says in the question, 0.24% per month. It's got the annual there, and it's actually hinting us that we need to work out the monthly ourselves. And then it's got the regular monthly payment of £250, and the balance immediately before the 1st of August 2024, and I think that's everything off of the question, so I no longer need the question in front of me. So we're going to work out this, so it's equals 1 plus the percent to the power of 1 over 12 minus 1, and that gives us our monthly percentage rate. Now we'll start working on our table. So we've got 1st of August 2023 has already been filled out, account balance before payment, then he made a payment, balance after payment. So I need to work out what to put in here. So he's put some money in August and it's £500. At the start of September then, a month later, his balance is going to be 500 plus the interest he gets that month, which is 0.24. So I need to have that in there, so round. And how do I add on interest? Well, I'll just put a 1 on it. So 1 plus this times the previous balance to 2 decimal places. And now make sure you dollar the correct amount. C9's outside the table, so F4 that, and press enter. 501.20. The payment is equal to always 250, and that's always dollared. So his balance immediately after the payment is simply this box plus this box. And then we can drag that down, but not too far. It only goes to the 30th of November. So there's October. Just double checking in your head that that's working. He gets a payment in October, and then he gets the interest for October, starting November. He gets his payment up to there, and then gets his interest for November to the start of December. So that needs to be copied down one more time. Where's our payment, our balance? That's for the interest in October. So here will be for the interest in November. We still get it in November at that rate. So yeah, we need another month. And then once we hit January, January will be December's interest. So we need to change the interest rate. So what you can do is just copy these boxes down again, just one time, but make sure you remember to change that one. So it's now no longer C9, it is now C12. So I can just change that number to 12. And there we are. Now we can copy down to here. And it says account balance before payment is made on the 1st of August. So that's your balance after payment here. Account balance before payment is there. So it's that number I need. So these two don't really need to be filled in. This is the number I need. So it's equals that number 3307.36. That's the balance before payment's made on the 1st of August 2024. Because then he makes his payment and then his balance after payment. 3307.36. Print the car finance worksheet in value view and formula view, and the savings account in value view and formula view. So just a reminder on how to do that. File, print obviously for normal, this is normal view, but if you want to see your formulas, you go to formulas and show formulas, and that's called formula view, and it starts to give you all your formulas as you go, and then you print that as well. And you do the same for both sheets. Value view, show formulas, formula view, and one. Application Maths 2024 question 6, and this is a spreadsheet question on Q6 Golf. A golf ball manufacturing company has designed a new golf ball which is more hard wearing. They want to determine if there's a difference in the distance travelled by current and new. To measure distances by current and new, a random sample of 40 were produced and subjected to a test, and they collected the data for distance travelled for both current and new. The data was found to be approximately normally distributed. Generate and state the appropriate measures of location and spread for current and new golf balls. So if it is normally distributed, you can use the mean and standard deviation. If there's a skew, you use the median and interquartile range. Make two valid comparisons about the driving distances of both current and new golf balls, so we can look at that when we get our mean and standard deviation. And then state appropriate null and alternative hypotheses. Do a hypothesis test, interpret a p-value. So we'll get to that when we get to that. Let's look up RStudio, because it's an RStudio question. So I've already loaded it in, and you're going to need the data booklet. So let's just get the data booklet ready. Okay, so there we go. So first thing we do is data booklet is my data read.csv. My data read.csv, and then it's called Q6 golf.csv. Just make sure you've done that correctly by checking my data, read.csv, yeah. Control Enter to run, and then attach my data. Okay, so we want mean and standard deviation. So I'm going to just split this into two. You would have a data book usually beside you. So I'm looking for, let me just unzoom this a little bit, descriptive statistics. So we don't want a summary because that's mean and median. We want the mean and standard deviation. So we'll just do it separately. So we need to know what the headings are called. So you can just click view file. We've got current and new. Great. So back to this, we want mean of current, should come up. We want standard deviation of current. And then we want mean of new. And we want standard deviation of new. So we get all that. So let's just copy that over to our Word document, statistical software output, mean standard deviation, mean standard deviation. And is that everything we have to do? Generate appropriate locations of location spread. Yeah. Make two valid comparisons about the driving distances of both current and new golf balls. So let's just put this in. Measure of location, meters, measure of spread. So location is the average, so it's 270.28. And the spread is 8.75, say. And then for the new one, it's 267.5. And the spread is 9.89 or 9.90. Any rounding you want. And then on average, using the mean, current golf balls travel further. 270.28 is bigger than 267.5. And then measures of spread. The distances travelled by current golf balls is more consistent than new golf balls. And that's because 8.75 is bigger than 9.90. Or you could say the distances travelled by current golf balls is less spread out, or the distance travelled by new golf balls is more spread out or less consistent. Okay, next question. The appropriate null and alternative hypothesis to determine if there's a statistically significant difference between the distances travelled by current and new golf balls. Okay, it's null. Let's look at a null hypothesis. There is no difference between the distances travelled by current and new golf balls. Alternative hypothesis. There is a difference between the distances travelled by current and new golf balls. Part C. State what type of hypothesis test appropriate to determine if there's a statistically significant difference between distances travelled by current and new golf balls. This can help you if you want. It's a t-test. Performs a two-sample t-test between two separate sets of data. It's not paired. It's just a normal t-test because they're independent of each other. So it is just a t-test. So we just type in t-test. And I've put my null and hypothesis, alternative hypothesis in the correct place. Now it says, perform the test, state the p-value, interpret the p-value. So let's go back to RStudio, t.test, and it was called current, and it was called new. Pretty sure that's how you do it. Control enter. So we get our Welsh 2 sample t-test. We can copy that over as a statistical output. And we want the p-value. There's our p-value there, 0.188. Interpret the p-value in the result of our hypothesis test in context. So, since the p-value of 0.188 is greater than 0.05, you fail to reject a null hypothesis. If it's less than 0.05, you can reject a null hypothesis, but if it's greater than, you cannot reject it, but you can't say it isn't there. So you fail to reject the null hypothesis. And what was our null hypothesis? That there was no difference in the distances travelled between new golf balls. So if we were rejecting the null hypothesis, we would say that we can accept that there's probably a difference between current and new golf balls, but since we're failing to reject the null hypothesis, we cannot determine if there is a significant difference between the distances travelled by new and current golf balls from this data. And that's that question done.
Down here for Clelland Maths, SQA, Higher Application of Maths 2023 question 5. This is the spreadsheet file Q5 coffee, where you have to construct a scatter plot of number of calories on carbohydrate content. So number of calories is the Y, carbohydrate content is the X. If you do a scatter plot, I usually use RStudio, I'm presuming you do too, and the data booklet is going to be handy for this. So let's go to the data booklet now. There is a data booklet for helpful R commands. The first one we need are my data and attach my data. Now I'm going to type this in, but you can actually copy and paste these as well, which is really quite handy. But I'm going to type them in case copy and pasting doesn't work for you anyway. So let's go to RStudio, which I've got it on the cloud, but you might have had it downloaded. Same kind of thing. You find your file on your computer and get it into RStudio first of all. And the first thing you're going to do is your my data. So my data up in the terminal, /- and it's read.csv, and then open brackets, inverted commas, Q5 coffee.csv, inverted commas and brackets, and then control enter to do that command. Now we need to do attach. So it's attach my data in brackets and enter, and that's us done our attachment. So now we need to plot our scatter plot. So you go back to your data booklet and go down to graphics, and you're looking for the one that says produce a scatter plot. So it's this one here. Okay, so let's go into RStudio and type that in, replacing the X and the Y, of course, with our variables, which are carbohydrate content on the X and number of calories on the Y. So plot, and then it's XY. So X is number of calories on carbohydrate content. So you write carbohydrate content first, carbohydrate.content, just click it, comma, number, just start typing it, and it comes up of calories. Name the x-axis, xlab equals inverted commas. So X carbohydrate content, and we're going to put our units of grams in there. And then comma, y lab equals, inverted commas again, number of calories. And we're going to give the units of that, which is kilocals. Okay, the next stage is to get our title. So to get our title, we put comma, space main equals scatter plot of number of calories on carbohydrate content. Now the last bit of the command, we have got PCH equals 21 and we have got BG equals inverted commas black. Make sure everything's closed up properly with inverted commas and brackets and press Control Enter. And you get a nice scatter plot of number of calories on carbohydrate content. That's has got our 2 marks. Part B. Find the correlation coefficient between the number of calories and carbohydrate content. And the data booklet is helpful for anything like this. Back to the data booklet, down to correlation and regression. The core test tells you the correlation coefficient. So it's core.test xy, nice and simple there. So back into here, core.test, x is carbohydrate content. So carbohydrate content, comma, number of calories. Control Enter. And we get an output. Interpret the correlation coefficient. Okay, so let's copy this into our answer sheet. So there's our answer sheet there. You can just copy your scatter plot, and then part B, your statistical output, that is our Pearson's correlation coefficient. We can put that there. We can write our actual answer, 0.9628262. You actually write the answer. It's checking you understand not to use any of the other values there. It's the correlation coefficient you're looking for. And interpret the correlation coefficient. Well, the correlation coefficient is close to 1, so we can say that it has got a strong positive linear relationship or association between carbohydrate content and number of calories. So let's just write something like that. There is a strong positive linear association or correlation between carbohydrate content and the number of calories. Part C of this question, find the equation of the regression line of number of calories on carbohydrate content, interpret the slope and intercept parameters. So back to data booklet for a regression line. We have got the second command here fits a linear regression line to the data. LM y tiddle x. So back to here, LM, writing it in the wrong place, make sure you're up there. LM bracket y is our number of calories, number of calories. Tiddle is shift hash on my keyboard, you'll just need to maybe look for it, but carbohydrate content, carbohydrate.content. Make sure the brackets close, Control Enter, and we get a output. Let's just copy that over to our answer sheet. So there's the output. There's our output. That gives us the equation quite easily. Because if you go back to, let's go to RStudio for a moment. Number of calories is up beside and carbohydrate content's on the bottom. This tells us that the number of calories, or just calories, equals the first number plus the second number times the carbohydrate content. So we just need to write that. So number of calories, I'll just type calories actually, you'll be fine with that. Calories equals 73.65 plus 4.65 times carbohydrate. And we have to interpret what that means. So let's look at the slope first. So this is this number here, 4.65. That's what we call a gradient in maths, and that tells you that if you go along 1 on the x, you go up 4.65 on the y. So the x is carbohydrate content, and the y is the calories. So the number of calories increases by 4.65 kilocalories for every additional 1 gram or g of carbohydrate. Every time you put a gram of carbohydrate in, 4.65 calories is added. Okay, the y-intercept, or we'll just write intercept. So the intercept is the first number, 73.65. That tells you what happens when there's no x, no carbohydrate. So in a drink with 0 grams of carbohydrate, there will be 73.65 kilocalories. And that's all you need for that. Part D, estimate the number of calories in a drink with 59 grams of carbohydrate. So let's look at our data booklet. So we're going to use the predictorand to fit that in. So let's go to our studio again. We're going to use predict. Put that up here. Predict. LM. And it's y to the x. So it's number dot of calories to the carbohydrate content. And then you put a comma after the first bracket. New data equals data dot frame, and then bracket x equals c. X is carbohydrate content, so carbohydrate content equals, and by c we mean the number, so 59 in this case. And then outside the bracket, interval equals pred. So in inverted commas, pred. Make sure everything's closed, control enter, and you will get an output. Let's copy that output, shall we? It doesn't ask us for our output, but let's just put it in anyway. That was our output. And then my answer, 348.0205. Oh, there's two other numbers, but notice it says fit, lower, upper. But we pick the fit, 348 kilocal, and we're done there. We'll then just print this off for our examiner, making sure that our name and our centre number and everything else you need is in that sheet.
Higherapps Maths 2025 question 12. You must refer to the spreadsheet Q12i colour when answering this question. Complete parts A, B and C using the spreadsheet file. A random sample of 50 children were invited to take part in a general health study and answer the following questions. State your sex, male, female, prefer not to say. State your eye colour, which is blue, brown and green. And are you colourblind? Yes or no? The responses from the survey were partially entered into the participant responses table. Participants 3, 7, 13, 18 responded yes to being colourblind. Participant 42 had withdrawn their consent for the responses to be included. Open the eye colour worksheet. With to complete the participant responses table using the information, complete the eye colour summary table, create an appropriate chart to display the frequencies of eye colour in the summary data. So let's have a look at this. So participant 3 was colourblind. I'll just write yes then. Participants 7 and 13 were colourblind, so I'll just copy that. 7 and 13 and 18. They're all colourblind. All other participants were not colourblind. So no. Now, be as fast or as slow as you want here. I'm just going to copy into all the spaces by highlighting them. Every time I see a gap, I'm just going to skip it and start again. Control V and Control C I'm using here. So Control C copies and Control V pastes. And we get it all in pretty quick then, instead of just typing it, because that would be really inefficient. You could also use YN if you prefer, or any other thing that you know would mean yes and no. What else does it tell us in the question? Participant 42 withdrew their consent to have the responses included in the data. So 42 is out. Delete. Goodbye. That's the only information we've actually got. So that's part A done. Part B, complete the eye colour summary table. So frequency means how many. And we want to know how many people have blue eyes, brown eyes, and green eyes. Now, I've had a lot of mentions about this question already. And a lot of people say, does that the count if thing? Do we use that? And you can. I mean, if you know how to do that, you should have hopefully had some training during the course on various Excel functions, basic ones. It's unclear at this stage whether or not you're getting a mark for using a formula here, because it does just say complete the eye colour summary table. It doesn't say you need to use a formula. So I think there is a chance that if you were to just count them blindly and shove in the number, you might get the mark. although I don't think they want you to do that. I think they want you to use a function. I'm going to use a function, so we'll not know until the actual mark scheme comes out whether or not you're getting a mark for the function or not, because the question doesn't tell you either way that you need to use a function. So, but I will use a function. So how do we use the countIf function? Well, we just type in here equals countIf, open a bracket, we want a range of data, so we highlight our data, or type it in manually if you feel you must. And then our criteria, now you can't just type in blue here, you need it in inverted commas, blue, because it's a word. Close your bracket, press enter, and you get 11. Let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 there. Same command again, countIf, same range. And now the word is brown, green, same command again, same range. And now the word is green. And that's it. We've got 11, 34, and 4. Looking back at part B, A, 42 had withdrawn their consent for responses to be included in the data. We could have done something with that, as in like highlighted it, put boxes around it to say don't include it. But I think if someone's saying you've not to include my data, it really is a case of saying, well, that's fine, it's deleted, it's not part of our table at all. So I think I'm quite happy that that's what they want you to do, but rather than just mess around with it. Create an appropriate chart to display the frequencies in the eye colour summary data. So for this bit, just this little table here, insert a little chart, probably a pie chart or a bar chart would be fine. Either one, anything that is reasonable. We've got an option of like a pie chart, a bar graph. When I click this, by the way, you don't see it on screen what it's shown me until I click one and choose one, okay? But I'm going to choose a pie chart because that seems best to me. You could have done a bar graph. Now, there's that. Now, that's not good enough. If I just have that, I don't think I'll get the full marks. I need to have a better word here, a better title. Pie chart of children's eye colour. There's my chart, and then data labels. You could put them in if you want, and it would tell you 11, 34, and 4, which is quite nice. You know, it's hard to say exactly what we would want, a legend for sure, but that's good. I'll show you what you would get if you were to actually pick a different chart as well. Let's pick a bar chart this time, down a little bit. So if we'd done a bar chart instead, you would get something like that. Again, you want your data labels in. So add axis titles, bar chart of children's eye colour, say. Axis title, eye colour, axis title, frequency or number. Frequency I'm quite happy with. You could even mess about changing these colours of the bars or anything else you wanted to do, but I think that's a reasonable chart as well. So we've got a couple of nice little charts and we're done there. Print the eye colour worksheet in formula view and value view. Ensure the chart is visible on one page. So as usual, file print, and if you want formula view, formulas, and then we go to show formulas and you get it, and then you go to file and print, and we're done there. SQA Higher Applications of Maths 2025 question 9. You must refer to information on feeding chicks. To monitor the effect of a type of feed on their mass, a group of chicks were randomly allocated 2 groups at birth. One group was given A and the second group was given type B. The comparative box plot summarises the mass of chicks in grams when weighed at 3 weeks old. Explain which type of feed results in chicks with the least variability in mass. Least variability in mass, well, there is an outlier for A, but taking that out, the box in whiskers was much shorter than for A than B, so less variable, less range. And looking at the actual box itself, the interquartile range is smaller for A than it is for B, because you get the interquartile range by taking away the width of the box. Basically, it's the width of the box, taking away the lower quartile and upper quartile from each other. So I would probably just say type A, because the box plot shows a smaller interquartile range. By box A, B being noticeably taller than box A. We could also mention that the range is bigger as well if you wanted to. The range of B is a lot bigger than the range of A. So you could say that if you want. Looking at the range, B is larger than A, showed by the difference in the whiskers. You could also mention this outlier here, or you could say known outlier, but to be honest with you, it's only worth 1 mark. I think that will be enough. Box plot A shows a smaller interquartile range, showed by box B being noticeably taller than A. I think that's enough. So question 9, part B, a hypothesis test is being performed to compare the two groups. State the hypothesis test performed. Well, we're going to be comparing the two groups, comparing the means, comparing the average weight, so it's a t-test. Okay, state the null and alternative hypothesis. Null, there is no significant difference in the mean weight of chicks, mean mass of chicks at 3 weeks old between those given food type A and food type B. And then the alternative hypothesis is just the opposite statement of that. There is a statistically significant, or just significant, will be fine, difference in the mean, because we're doing a t-test, mass of chicks at 3 weeks old between those given food type A against food type B. P-value was 0.003147. Interpret the p-value in the result of the hypothesis test in context. So we've got p-value of 0.003147 is less than 0.05, so we can reject the null hypothesis. And say, therefore, there is a statistically significant difference in the mean mass of chicks at 3 weeks old between those given feed A against feed B. So you could mention a 95% confidence interval for the true population, but I don't think you need it for this question. I think that is enough. It's just really wanting you to say, what does it mean to reject the null hypothesis for this question? The type of feed used for one group of chicks is sold in 4.5 kilogram bags. The nutritional content is shown. Explain whether this nutritional information is more likely to be for type A or type B. So if we go back up here, the mean or median mass of chicks here is just over 150, whereas for type B, it's about 250. If we look at our data booklet, it says specially formatted data will help them grow at an early stage of life required. Specialist chicks foods recommend up to age 6 weeks old. This type of feed has between 20 and 24% protein boost to enable them mass appropriately and feather out rapidly. At 3 weeks old, chicks typically weigh 200 grams. If they've not been fed a specialist chick feed, they're likely to experience stunted growth indicated by a mass of under 200 grams. At 6 weeks old, the chicks slowly transition to another type of feed. So between 20 and 24% protein allows them to increase their mass. So let's check the protein content of this feed. Well, we've got 720 out of 720 plus 150 plus 320 plus 3310 is 4,500. And to change that to a percent, we would times by 100 once we've divided. So that's what I'm going to do. 720 divided by 4,500 times 100 is 16% protein. So if it's got 16% protein, that means that it's got less than the 20 to 24%, so it's probably stunted growth. So if we look at our graphs, the median mass is under 200 for type A and about over 200 for type B. So it's likely. So we can say type A as this is below the recommended protein content of 20 to 24%. Data booklet says if less than 20 to 24%, likely to have stunted growth. Graph A shows median mass of less than 200 grams. Data booklet says less than 200 grams at 3 weeks is stunted growth. Where B has median mass around 250 grams, which is much higher than the minimum of 200 grams. Obviously, I've over-egged this and said probably a lot more than you have to say, but essentially that's it. Type A is its below the recommended protein content of 20 to 24%, and this causes stunted growth according to the data booklet, and graph A is showing stunted growth because the median mass of chicks is less than 200 grams, which is what the data booklet says would be stunted growth. And we're done there. Maths 2024 question 4. You must refer to the pre-release information on Dracania plants and carbon dioxide levels. Let's read it first though. You've got to fill in a spreadsheet and complete it in the answer space provided. In fact, if I tutored you, you'll realise that I predicted that this would actually be the question. It's exactly the same question I told you it would be. So a research scientist is studying the effect of Dracania plants to improve air quality. Large ones reduce by 13% in the showroom, and each evening the heating's left on and it adds CO2 to increase it by 180. At the start of the study it's 2000. Complete the worksheet to estimate the CO2 at the end of 30 days. And here's the worksheet. It's already filled in some of these boxes for you, but you need to fill in some more. But let's look at the pre-release material and make sure we don't miss anything. So there's the pre-release material. It just talks about the type, what these plants do, reduce CO2. It says they're used to try and improve levels of CO2 levels. We're measuring parts per million. And it says acceptable levels in the UK are 800 for very good air quality, below 800, and above 1500 is poor air quality. When it's identified, control measures need to be taken to improve ventilation. Okay, so let's go to our spreadsheet. Starting with 2000, it's reduced by 13% from the plant, so we need to work out what's left. So to work out what's left, it's just equals 1 minus that box if it's been set up correctly. Yep, 87%, or check your calculator. And then additional levels emitted by the heating system is 180. We have to do it by the end of 30 days. So let's fill in a formula here. This is your recurrence relationship question. So you're doing 2000 times, and level at the end of the day, that means there's 87% left at the end of the day. So I'll put dollars around that because that's outside the box. And then we're adding in at the end of the day as well this 180. So again, that's outside the box, so we're putting dollars around that. Now, in terms of rounding, this is not money or people, so you could kind of just not round it and you would get lots of decimals, but it's going to look nicer if you do round it. And since we're estimating how much is there, I'm going to use the int command for this because that'll just give me it to truncating it, taking away the decimal points. Or actually, let's round it. Let's round it to 2 so we can really see what's happening. Do that to start with. We can always adjust it if we prefer to adjust it later. So then 30 days, 26, 29, 30. So we've got 1394.05. I think I'm going to round that to no decimal places, I think. Or again, use the int command. And there we are. We get a nicer number, 1394. So CO2 levels at the end of 30 days is 1394. Next bit of the question says, extend your table for 60 days. Well, actually, let's read it. Research scientist investigates the long-term CO2 in the showroom. Extend your table to the end of 30 days and construct a graph to show what will happen in the showroom. Include titles and axes. So 30 days we've got, so we just copy it down until it says 60. And we can see it's starting to level off. We're getting the same number. So I expected that to happen, to be honest, as what I was looking for, but maybe you didn't. Insert recommended charts and just pick one that looks good. Don't pick one of these bars, that's not going to help, but one of these is fine. You've either got the scatter or the line, or if you don't go to insert, you can just go here and click charts and then just click scatter and pick the one that you like the look of. So there we get our scatter. Let's just move this up so we can see it next to the table better and we can work on it. And let's make it a little bit bigger. So, title, CO2 levels at the end of each day in the showroom. And then we need to add our axis labels, so axis titles, CO2 levels in parts per million. I'm going to make that too small just because it is a subscript, but you probably won't have to do that. And then this one is just day or end of day. And there you go, we've got a nice graph. Part C, explain whether Dracaena plants are effective at obtaining very good air quality in the showroom. Well, you can see it levels off at about 1300, 1388 here. And to get very good air quality, you need it to be 800 or below. So no Dracaena large Dracaena plants are not effective at obtaining very good air quality in the showroom, as CO2 levels will not go below around, what do we get? 1388 parts per million in the long term, and 1388 parts per million is greater than 800 parts per million. And I think that you'll be fine with that. So let's see what else to do with this question. Just print it in value and formula view. So you just go to File, Print, that's just value view. You have to make sure that your graph is beside the table and on one page. So fit on one page, which I've already sheet on one page, that's fine. And then if you want formula view, you go to Formula, Show Formulas, File again, Print, and you can see it on Formula View there with all the formulas shown. And that's us done for that question.
ASCII High Application Maths 2022, question 5. You must fit the spreadsheet school rule. Question 5. When answering this question, complete part A1, C1 using this file, and then complete parts A2, B, C2 using the answers below. So let's read the question first. A school is planning a new building and it is approaching maximum capacity. The school rule in August 2021 was 650 pupils. Approximately 18% of pupils leave by the end of each school year, and 140 new S1 pupils join the rule in August each year. We have to complete the school rule worksheet to predict the school rule in August 2031. So let's go into the spreadsheet. So you just put your dummy name in here. So Clelland Maths, of course. Secure candidate number 0123456. Set a name is set a name, whatever you form. Right, let's go. The number of pupils in August 2021 is 650. And we've got 18% leaving. If 18% are leaving, that means that what's left over is equal to 100 minus 18. Now you can get a calculator and work it out if you want, or just press equals 1 minus this box, and it hopefully will do it for you, 82%. If it doesn't work out for you, just get a calculator and type it in manually, 82%. Okay, S1 intake is 140. We have to work out this one, so we're going to have to go into our table. So we'll have to think about what we're actually trying to work out. If 82% are left at the end of the year, then this box is going to equal, let's just take the forward first, I'll do rounding later, but it's going to equal essentially this box, which is 82%, times 650, but we don't want to type 650, we want to reference the previous because we want to do it every time, plus, and we want to add on 140 each time, so this one. Now, that's a basic version of the formula, but there's certain things we need to be aware of. If things are outside of the table, we usually use dollars because we want that to reference that cell and keep that cell referenced all the time. So that's a good rule of thumb. So what is outside of there? Well, we've got D9. So $D, $9 is what we want to put. So we can put that in. And then we've got D10. So $D, $10. And then C14 is fine because we want that to change each time. If it's inside the table, usually you want that to change each time so you don't dollar it. So we've got that to start with, and that would be fine, but we're not rounded. Have a look at this. It's approximately 18% leave, and the number of pupils has to be a whole number. So we can just round this to 0 decimal places. You could also use the integer function if it's exact, but we're looking at rounding here, so just round. And then press enter. And we get 673, and we can just extend that by dragging and dropping, or double clicking, or copying and pasting. And we get an answer of 761. So we have answered part A. So we'll just type that in here, 761, job done. Part 2, comment on the precision of this prediction. Well, the number of pupils leaving each year is approximate. So the prediction is approximate as the number of pupils that leave at the end of each school year is approximate. And with these questions, usually when you're talking about precisions of predictions, if we go back, we look at the variables that could change. For instance, the levers could change, but really, the S1 intake, is that really 140 each year? The question says it is, but that could change too. So looking at these questions, you're looking at just making a comment on these numbers being accurate or whether they can change or not. Part B, comment on the relationship between time and predicted school roll up to August 2031. So let's have a look. As each year goes on, the number of pupils increase. So that's all we have to write. So the number of pupils gradually increases each year. The school moves forward with plans for a new building. This will increase the capacity to 800 pupils. Extend the table on your worksheet to construct a graph to show what is predicted to happen to the school roll in the long term. You must consider what happens beyond August 2031 and then use your graph to determine whether the new capacity is suitable. So let's go back to our graph. We need to extend our graph so we can just highlight and we can start dragging down and just see what happens. Well, it just looks like it's still increasing, so I'll keep going. See if there's any actual, there's a pattern there. So have a look there. We can start to see that it's given us the same number. Do that a few more times just to check. And generally speaking, with a question like this is what you're looking to happen. So we get that. And then we have to make a graph. So let's highlight all the data and don't give ourselves a headache. Insert, recommended charts. Top one looks good. So I'll just press OK. And I'll move that up so that it's in an appropriate place. And let's just make sure the axes are labelled. So graph of number of, well, let's just call it school roll against year. That seems good. So a title for a graph, and then axes, so plus axis titles. This one's number of pupils. And this one is year. So we've appropriately labelled on a graph, just in case there's a mark for that. Now in this question there wasn't a mark for that, but there will be a mark for it somewhere probably. So just make sure all graphs are appropriately labelled whenever you do them. Okay, so we've done a graph. Let's go check the question. Extend your table and construct a graph to show what's happened to school in the long term. Well, we've done that. So there's your 2 marks. We've extended the table with the constructor graph. We've made sure that it does something that levels off and we go far enough. If in doubt, go too far. Don't do too little. Use your graph to determine whether the new capacity is suitable. So the new capacity is 800 pupils. Well, there's my graph there. Now this is an exponential graph. And you can see that it's going up and then levelling off. Or you can see that in the table it's levelling off at 776. Now the capacity is 800, it says. So for part 2, yes, the capacity of 800 is suitable as the number of pupils levels off or never exceeds 776. And that will give you your mark there. And then it says to print the school worksheet in value view and formula view. So value view and formula view on one page. So just to click, this is a value view. So we just go to File, Print, Fit Sheet on one page, and then you'll get it all on one page. So that's value view. But for formula view, you go to Formulas, and you go to click here, Show Formulas, and then it will show all the formulas that you've used. So at SQ you can mark it and make sure you've rounded. File again, Print. Make sure you click to fit on one sheet, which is done, and then you just print it and away you go. Just a little note on this. We may ask you, it's come up before, we'll just get rid of these formulas. This graph is called an exponential graph. So this is called exponential growth. If it goes down the way, it's called exponential decay. The other thing you could call it is a recurrence relationship. This is actually doing a recurrence relationship because it's using the previous value to get the next value over and over again. And that's done for this question.
Next we have Piece of Maths 2025, question 1. Estimate the number of portions of fruit and veg that a typical person eats during their childhood. Now, I've got a bit of bone of contention with this question just to start with, actually. Childhood, what does that mean? That can vary by culture, what a childhood is. But in the UK, a child is defined as up to about 18, usually. So I think using that, but I think this is a Fermi estimate. So as long as your assumption is reasonable, I think we're okay. So I'm just going to assume, let's say 18 years of childhood. In fact, I might go a little bit lower than that and say 17 years. Let's say as a baby you don't eat very much, so you've got up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, let's just assume 18 years. Why not? Let's go 18 years. I think you'll get away with anything that seems reasonable. If you're assuming that 12 years of childhood or whatever, you can never tell till the mark scheme comes out. But it's the method that's important really for this question, because it really is pretty simple after that. Assume how many portions? Well, whatever you think. Standard, I think, in my head is 5, isn't it? So 5 portions per day. And we're going to assume 365 days a year. We're going to skip these leap years. Yeah, that'll do. So we'll just do our sum. 18 times 5 times 365. Get a calculator. Which is 32850. But again, I must stress, your answer may be wildly different from mine, because you might have made different assumptions. The question's about, can you make reasonable assumptions and do a sum with it? It's always going to be a time sum. Okay, SQA Higher Application Maths 2022, question 10. You must refer to information mountain gorillas given in the pre-release material, so we'll look at that in a minute. The 2020 study found that the population of mountain gorillas has increased to 1,004. And an expert has stated that if the mountain gorilla population in Virginia mountains continues to go exponentially, there will be 1,600 by the year 2032. Determine if he's correct. So we're going to have to look at this pre-release material to see if there's any information to help us with this. It says deforestation happened on a massive scale, blah, 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 blah. A study in 2008, starting on this paragraph, said there was only 680 mountain gorillas in Virginia mountains. A study in 2020 showed that due to conservation efforts clamping down, that had increased, and we know what that's increased to. And we'll come back to this a little bit later for the rest of the question, but we do know that in 2008 there was 680, 2008 there were 680. We know in 2020 there are 1,004. Now the way exponential growth works is, if over a certain time period, like 10 years, something had doubled, it will keep doubling every 10 years. So this is 12 years, and we now want to know 2032. So let's just check that time period is the same, 12 years, 12 years. So if I know what that's times by, for the next one it'll just times by the same amount. So how do I know the multiplier? I just do 1,004 divided by 680. That's 1.476. I'll take a note of it as a truncated amount, but I'll just leave it in my calculator. So that means to get to the next one, I'm going to times by 1.476 as well. So I'm just going to times 1,004 by that, so I'm just going to press times 1,004. That gives me 1482.376. So that's about That's about 1482. Just rounding down because it's a whole number of gorillas. So that means that the expert is wrong, because 1482 is much less than 1600, and for exponential growth to occur, 1482 must be the number. Adult mountain gorilla eats 30 kilograms of food per day. Estimate the amount of termites and ants in kilograms that a typical mountain gorilla will eat during their adult lifetime. State any assumptions you make. So this is called a Fermi estimate. So we're looking from the second paragraphs. Mountain gorillas are considered adults when they're 10 years old and live an average of 35 years. So there's a trick. It's not 35 times by, it's 25, because they're adults when they hit 10. And the second trick, mountain gorillas survive mainly on a vegetarian diet consisting of bamboo shoots, fruits and berries. Given the opportunity, they will also eat ants and termites, but their diet will remain mostly vegetarian. So what does that mean? Well, if you're mainly or mostly something, it means you eat more than, or do it 50% of the time or less, more. So if you're going to pick the amount of termites or ants that the gorillas eat, you have to pick a number less than 50%. So we're going to assume they live, adult life is 25 years. We're going to assume the usual, that there's 365 days per year to get rid of the leap years. We've got that, we've got to estimate the maximum amount of termites. So the maximum will have to be less than 50%. So let's just what's the closest to 50% we could be? 49.99% or 49%. I'm going to assume 49% of termites per year. Now it has to be 49% because it's the maximum we're looking for, so it's not just any old. So then we're just going to do 49% of 30 times 365 times 25. So 0.49 is 49% times 30 times 365 times 25. 134,137.5. That's about then 134,000 kilograms, thereabouts. The data, if you look at it, is given to two significant figures, 1600, 1004. So 134,000 is reasonable, but you'll get an answer for anywhere between 130 and 140,000 as long as you've rounded it somewhere reasonable. But the key point of this question is 49%. Higher Application Maths 2025, question 10. A cylindrical container has been filled with water. Initially, the depth of water is 4. The depth of water in the container increases at a constant rate of 3 centimeters per minute. It takes 8 minutes to finish filling the container. Draw a graph to model this. Well, it's just going to be a linear model because the depths just stay the same over time. So if we watch this, initially the depth is at 4 centimeters. Initially, the depth is up the side and time is along the bottom. So at time equal to 0, I am marking off 4. So that's just right there. It then says the depth of water in the container increases at a rate of 3 centimeters per minute. So every 3 centimeters, every minute we go up 3 centimeters. So if I go along 1 minute, I need to go up 3 centimeters from 4, so that's 7. So 6, 1, 2, 3, 4, 5 in the middle there. And I'll keep doing that. But then it takes 8 minutes to finish filling the container. So we need to do that for 8 minutes. But you can kind of work out straight away that 8 times 3 centimeters per minute means it will go up to 24, but it's 24 plus the 4 we started with, so we need to end at 28 centimeters. So you could just do that and say 8 minutes later, making sure I'm on the right line, and go up to 28 and see where that joins up. So that lines up, and then just join up the dot from the start to the end, and you've modelled your relationship. You could check that you've done it right by checking your points. It goes along 1, and every time it goes along 1, it goes up 3. So there we are. Get the idea. On an iPad, it's difficult to get that exact. State the type of relationship modelled in your graph. Well, it's a linear relationship because you've got a straight line. State the dependent variable. Dependent variable, well, the depth of water is dependent on time. As time changes, the depth of water changes. So the y-axis is always a dependent variable. So the depth of water. In centimeters, obviously. Question 10, continued. Another container shown below. The container is filled with water at a constant rate of 5 cubic centimeters per second. 3 graphs are shown below, showing how the depth of water in the container changes over time. Explain which graph could model the depth of water in the container. So we've got graph A, B, and C. Well, what's happening? If I put water in, it's going to be fast at the start and get slower as we go up. So we want something that gets fast at the start and gets slow as we go up. Well, that doesn't happen at B, that's just the same over time, so it's not B. A and C, we've got a choice of now. Well, that's actually getting faster as it goes. That's getting slower as it goes. It starts fast and gets slow as it goes, so it's graph C. So how could we say that? Well, we could say that narrow at bottom means depth changes fast at start and slower as container fills. B shows fast rate at start, tapering off or getting slower towards the end. And we're done there. This has been Clelland Maths, and today we've done the Higher Applications of Maths Ultimate Pre-Roll Revision Special. Hopefully you found that useful, and you hopefully have a fantastic 2026. Good luck in your exams, take care, stay safe, and goodbye.